Alright, so we left off in class and we were trying to determine the difference between what the end behavior showed us, which is this value right here, and what the technical approach for finding the slant asymptote of a function showed us. If you were in C block, we didn't discuss this because in A block we ran into the issue of why aren't they the same. But the real rationale for why they're not the same has to do with the way that this limit form that I'm boxing reduces. It simply doesn't reduce into the slant asymptote. It merely tells us about what power, specifically in this case x to the first power, determines the end behavior of the function. So we can merely use that approach of finding the behavior as x approaches infinity to tell us that there is a slant asymptote. Right? We can learn that there is a slant asymptote when we have a leftover piece after plugging in infinity to our new limit form. Then we have to go and take the technical approach and divide the denominator into the numerator. And what happens when we do so is we get x minus 2 over x minus 1. Right? So this is the same function, just written in a different way. Okay, that's still our original function, f of x equals x minus 2 over x minus 1. And the key that we want to recognize is that this first part, the part that doesn't include a denominator, right, represents the slant asymptote for the function, which in this case is the line y equals x. Okay, so that counts as the slant asymptote. Now what that means is that the graph of f of x follows the behavior of y equals x as x approaches either positive or negative infinity, meaning that it should essentially look like a line. Right? The reason we call it a slant asymptote is that the graph should begin looking like it follows the line y equals x the farther out it goes towards positive or negative infinity. So instead of drawing a horizontal asymptote for our graph, we're going to draw the line y equals x as part of the graphing process. So we can go back and pick up the information that we started with for this problem. And if we remember that there's a vertical asymptote at x equals 1. And we also found out that there are x-intercepts at 2 and at minus 1. And we found out that there is a y-intercept at 0, 2. And the last thing I'll do is I'll add in the line y equals x. Alright, now, we have to decide how it is that we're going to graph this equation. Right? We have a lot of points where we're not entirely sure what the behavior looks like. However, we do know where the graph is going to cross from positive to negative. Right? We can see at the x-intercepts, right? Those are the places where we'll cross, as well as at the asymptote itself. So one of the things that we could do here, and what we'll do for the graph, is we should evaluate this time. Right? Let's do a little sign analysis for the graph. So here's f of x. On my sign analysis, I need minus 1, I need 1, and I need 2. And remember that if I write the factored form for the expression, it's x minus 2 times x plus 1 all over x minus 1. Okay, let's pick a value. So I'll pick x equals minus 10. If I do so, that's negative times negative over negative. And negative times negative over negative is going to result in a negative region. Alright, we'll pick 0 in between. And when I pick 0 in between, I get negative times positive all over negative. Multiply that all out, I get a positive region. Lastly, between 1 and 2, or actually 2 more. Between 1 and 2, I guess I got to pick 3 halves. 3 halves gives me negative, and then positive, and all of that is over positive. So this overall region is negative. And finally, I'll pick x equals, I don't know, 1 billion. It's kind of running off the edge of my screen here. But let's just pick 1,000. And if I pick 1,000, I get positive, and positive, and positive. Notice how as we move from left to right, if you look at that sign analysis, one factor changes from negative to positive as we move from left to right. Just an interesting pattern to take a look at. Right? How each time we cross an x-intercept or each time we cross a vertical asymptote, one of the factors, right, one of the pieces in my sign analysis changes from positive to negative, and just one every time we cross one of those x-intercepts. That's a pattern that we should pay attention to. It tells us a little bit more about what's going on. So that means that to the left of -1, I have to be negative, and because I know I have a slant asymptote, I'm simply going to draw the behavior of the graph like so. I'm going to continue on up to the vertical asymptote. And you can see the way that I allow my graph to start mirroring the behavior of y equals x. And then on the other side, I know that I start down, hit the x-intercept, and then I've got to come up and level out with the slant asymptote. Okay. Check to make sure that the sign analysis makes sense with the graph that we've drawn. Well, that's how I would deal with a slant asymptote as opposed to a horizontal asymptote. Not a technique, right? Not a discrete method for each one, rather an understanding of what it means to have specific end behavior. The difference between having end behavior, which is a height, versus having end behavior, which follows the pattern of a graph. We'll see this grow more complicated as we get into different problem types, but for now, you should be ready to do the homework tonight.